All right, so we're going to talk about how to solve equations and formulas. Really, all we're doing here is what's called isolating variables. So we're just trying to get variables all by themselves. Okay, so let's assume that we had a case here where we had a is equal to m plus n, and they ask us to solve for m. So what they want you to do is get m by itself. And all you're going to do on these is you're going to follow the typical rules that you normally follow when you solve equations from Algebra 1. I'm assuming that you're in an Algebra 2 level class at this point. If you were going to try to get m by itself, you would want to get rid of the n that's with it. So the best way to do that is to subtract n from both sides. What's weird here is, so the right side just becomes m. What's weird and what makes people feel uncomfortable is thinking about what is a minus n. I don't know what that is. It's not like a number. So what do? Literally all you write is just a minus n, and this is it. All we're trying to do is figure out how to express m in terms of the other variables. That's what it means to solve for m. So that's it. Obviously, we have more examples and more difficult ones, but that's the idea. You're just trying to get the variable all by itself, and you're going to follow the same rules of adding, subtracting, multiplying, dividing. Later, we're going to get into stuff like square rooting and logarithms and stuff like that. But for today, we're just going to stick with relatively simple things. Okay, so what if we have this, and I ask you to solve for c? I want you to get c all by itself. So at this point, we've got c times x plus m is equal to y, and we want to get c all by itself. So I'm going to recommend, some of you are going to subtract m from both sides. Some of you are going to want to divide by x. And I'm going to say that personally, you could do either one first, but personally I think it makes more sense to subtract m and then divide by x here to get c by itself. If you divide by x, that's fine. But what you have to do is everything in here needs to get divided by x. So what that'll do is that'll get you just c over here. And then you'll have to subtract m over x to both sides. That's fine. You can do that. It just seems like more writing and a little confusing. So what I'm going to do is I'm going to subtract m from both sides. That's the first thing I'm going to do. So on the left, we're just left with cx, and on the right, we have y minus m. I don't know what y minus m is. It's not like a number, so I'm just going to write y minus m, because that's all I can do. From here, now you can divide by x, because we're trying to get c by itself. So divide by x. And your final answer here, the x's are basically, when you have x over x, it's 1, so it's basically kind of nothing. It goes away. So you'll be left with c is equal to y minus m over x. You could also have y over x minus m over x. You could have that. That's also equivalent to c. I just like this form right here. I'm happy with that. All right. Let's look at some more examples. Here's a third example. What if you have a familiar formula? Hopefully this is familiar to you. A is equal to 1/2 times b times h. This is the area formula. Part of the reason that we make you guys do this and isolate variables is because sometimes we have formulas that only find one thing for us. In this case, this formula is set up in such a way as to find area, and it assumes that you have base and height. But we encounter many situations where we have, say, maybe the area and the base, and we want to know what the height is. Now, you could do the math and work it backwards and problem solve, but sometimes it's nice to actually just get h. So let's say we want to get h, solve for h all by itself. Then you can just plug in a and b, and you don't have to like work it backwards or problem solve anything. So okay, so if we were going to solve this for h, we want to get h by itself. The only issues we have to worry about are the 1/2 and the b. Those are both multiplying the h here. So if you'd like, you can divide by 1/2, and then you can divide by b. That would work. That's not wrong. typically the way that I like to explain this to students is I personally would take care of the 1/2 first. So what I'm going to do is I'm going to actually multiply by 2 on both sides. Now, that is actually the same thing as dividing by 1/2. If you divide by 1/2, it's the same thing as multiplying by 2, which is kind of interesting. So on the left, we have 2 times a is 2a. When you multiply the right side by 2, I like to cross out these 2's, which means that they've essentially canceled each other out. They are an equivalent form of 1. So we're basically multiplying by 1. So I'm not going to bother writing this 1 here, because 1 times BH is just BH. It wouldn't be wrong if you had the 1 there, but it's not necessary. Okay, so what's our goal again? We're trying to solve for h, so we need to get h by itself, which means we need to get rid of that b. Since the b is currently multiplying the h, I'm going to suggest that we undo multiplication, and the operation that undoes multiplication is division. So we're going to divide by b on both sides. When you do that, I like to draw a line through the b there. On the right, I just have h, and then on the left, I have 2a divided by b. And that right there is how you solve for h. So we've got h all by itself there. All right, let's do another example. How about example number 4 here? What if I have 1 minus y over 2n? Let's say I make that equal to 4. And I ask you to solve for y. I'm just going to try to make these progressively slightly harder for you. Okay. Oh, that's not what I wanted to do. Okay. I'm just going to move over here. Okay, so if we're trying to get y by itself, we've got several things to take care of. We've got the 1 to take care of. We've got the 2n to take care of. We also have that negative there, which we need to get rid of. Now, a lot of people get stuck on these and they say, well, what should I do? Should I add y to both sides first? Should I multiply by 2n? Should I subtract 1 first? Because those things some form of those things need to happen at some point. And what I'm going to recommend here is when you have something like this, the first thing I would do, I would not add y and I would not subtract 1, because if you subtract 1, you're not really subtracting 1 here. Like, it would not truly get rid of the 1 here if you just subtracted 1 from the left side. What you should do is get rid of this fraction here, get rid of the bottom part of the fraction. So when you've got a 2n there, I'm going to multiply it. I'm going to suggest that you multiply both sides by 2n to start out with. So what would we have here? On the left, when you multiply by 2n, those essentially knock each other out. So you're left with just the top part, which is 1 minus y. And on the right, you're left with 4 times 2n, which is 8n. And so now we're trying to solve for y. There are several ways you can do this. Some people like to add y to both sides, and then they would subtract 8n. That's fine. Typically, the way I think about it is I will think of subtracting 1 here from both sides to get rid of the 1. So I'm left with, please, 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 write negative y. A lot of people forget to include that negative right there. So negative y is equal to 8n minus 1. I don't know what 8n minus 1 is. Please don't put 7n or 7, because 8n and 1 are not like terms. You can't combine them. Okay, so 8n minus 1. Now, the only issue here is we have negative y is equal to 8n minus 1. So what we're going to do is we're going to multiply both sides by negative 1. And this is where a lot of people make mistakes. And please, this is not subtracting 1. We are multiplying by negative 1. So on the left, when you take negative 1 times negative y, you'll get y. And on the right, that negative 1 needs to go to both the 8n and the negative 1 there. So what's going to happen here is it's going to switch around the 8n to negative 8n. And then this negative 1 right here is going to become plus 1. You'll see many people write this, they'll switch the order. They'll put 1 minus 8n. That's fine. Both of these are fine. I kind of prefer this form. I like to have that first term be positive, but if you have negative 8n plus 1, that's fine. It's not wrong. All right, let's look at another example. what if I gave you m times n is equal to a over c, and I ask you to solve for c. So solve for c. So what I would recommend on these is multiplying both sides by c. Some people want to divide by a, but the problem here is if you divide by a, you're still left with a 1 up here. So you'd have 1 over c is equal to mn divided by a, and you wouldn't really be much further along than when you started. So what I'm going to recommend here is multiply both sides by c. So we'll do that. And when we do that, on the left we'll have c times m times n, which I'm just going to write cmn. And that's going to be equal to, when you multiply by c here, the c's get rid of each other and you're going to be left with a. And so now the direction said to solve for c. So we're going to have to get rid of the m and the n in this case. You can divide by m and then divide by n, but I like to just do it all in one motion, one step. So I will divide by m and n at the exact same time. So when you do that, the m and the n get rid of each other. So we're just left with c is equal to a over mn. And that's how you would do that one. Let's look at another one. Number 6. And this is where they start to get a little weird. Many of you will track with me just fine and probably could have done these without much help. But this is where a lot of people start to have trouble. What if this had asked you to solve for y? So you've got ay plus 4y is equal to 2x minus 3, and this is asking you to solve for y. So the problem here is that you have a couple different y's. And so how, if you're supposed to isolate or get the y by itself, how are you supposed to do that if there's two of them? The way that you do these is you divide the left side by y. And I'm not going to write it like this. I'm not going to divide it by y like that. What I'm going to do is I'm going to pull the y out of each of these terms. So this is kind of like doing distribution backwards. So you'll remember if you have like 4 times 3 plus 2, you can do 4 times 3 and 4 times 2, so you'd get 12 plus 8. That's called distribution. What I'm doing is essentially going, instead of going from this step to this step, I'm going from this step back to this step. So what I'm doing here is I'm pulling a 4 out of both of these terms, and I'm saying, hey, I would have been left with 3 and 2 here if I had pulled a 4 out of both of these terms. Okay, so we're basically doing reverse distribution here. So, with that in mind, what would we have left after we pull a y out of a times y? We would just have an a left. And what would we have left if we pulled the y out of the 4 times y? We would just be left with 4. If you're not sure that you did this correctly, just go ahead and take what you wrote and distribute it and see if when you distribute it, you end up with what you started with up here. So if you think about it, if you do y times a, you would get ay. And then if you do y times 4, you would get 4y. So we're good. We did that reverse distribution correctly. All right. And then on the right side, I'm not going to change anything. So I still have 2x minus 3. So we're still trying to get y by itself. And let me ask you this. If you had y times 7 was equal to, something over here, you would divide by 7 on both sides, right? You're going to do the same thing here, except what I want you to realize is that a plus 4 is its own full thing. So what we're going to do is we're going to divide the entire left side by the entire quantity a plus 4. We're going to divide by that entire quantity. And since we do it on the left, we're going to do it on the right as well. So when we do that, the a plus 4 here and the a plus 4 here, if you take a plus 4, divide it by a plus 4, you get 1. It doesn't matter what a is. That will always be 1. So you'll just be left with 1y on the left. I'm just going to write y. And on the right, we'll have 2x minus 3 over a plus 4. You don't really need the parentheses on the bottom there. I just like to put them sometimes. So this right here is y all by itself and isolated. All right, let's do a few more examples like this, and then we'll be done. So what if I had 3n minus xn equals m, and I asked you to solve for n? So 3n minus xn is equal to m, and I asked you to solve for n. So we're going to do the same thing. So we're going to pull that n out. We'll have 3 minus x. That would be what would be left after you have divided an n out of each of those terms on the left side. And that's going to be equal to m. Not really doing anything to the right side. And then same as last time, in order to get n by itself, we're going to divide by the entire quantity 3 minus x. And we're going to do it on both sides. So our answer here, after those get rid of each other, would be n is equal to m over 3 minus x. That's how you would do that one. Okay, just want to do one more like that. Then we'll be done here. All right, so 8. What if we had xy is equal to 2 plus y, and I asked you to solve for y? Go ahead and get y by itself. What you're going to do here is, and the only reason that this is more complicated than the last problem is because we've got a y on the left side and a y on the right side. So what I generally recommend doing is getting it so that the variable that you're trying to solve for, if you have multiple variables that you're trying to solve for, get them both on the same side. So in this case, the n's were already together on the left side. So what we're going to do here on number 8 is we're going to bring the y from the right side over to the left side, just to make sure that we're all on the left side. So what we're going to do is we're going to subtract y from both sides. When we do that, it gets rid of the y there. So on the right side, we just have 2. Be really careful. If you have xy and you subtract y, it doesn't just become x, because these aren't like terms. So it's got to be on the left side, you'll have xy minus y. It's very, very tempting to just say, oh, xy minus y must be x, but it's not. Okay, so now we're here, and now we can do what we've been doing for the last couple steps. So we will pull the y out, and we'll divide. If you took xy and divided by y, you would be left with x. Here's an interesting question. If you have y and you divide by y, what do you have left? So I think it's pretty clear to see if you have xy divided by y, that must just be x. But if you have y and you divide by y, what's left? It's just 1. So this will be 1 right there. And now that we're here, you can divide both sides by this entire quantity, x minus 1. Do it on both sides, and you'll just be left with y is equal to 2 over x minus 1. And that would be your answer right there.